We are on the page 15, section 2.2, evaluate algebraic expressions. Last time we talked about numbers, positive, negative, how to operate them as subtract, right? Multiply and divide. Also, we talk about, what else? Order of operations, right? You have to follow certain rules to do that. So today we are going to talk about expressions. Math language we call it expressions. Okay, algebraic expressions. So we are going to translate the English to math, then see what do they mean, from English to math. And there are some facts. When you use the calculator and computer, you need to pay attention to parentheses. We talk about that later. Let's see some examples first and see what's the difference if you have a parenthesis or not, right? So first one, we say evaluate x plus y over 2. Then x, say, what is this? What's the value of that? We call evaluate, right? So when x is -7, y is -3. So in the meantime, you are learning the symbols, x and y's. All right, then we connect them with the meanings and words. So for the math part, so x is -7, y is -3. What's the value of this guy, right? So that's what we want to do. So what do you think? You plug in -7 plus -3 divided by 2, right? Then we know fractions, this line is a group symbol. So you have to do it top and bottom separately before you put them together, right? So you have -7 plus -3, -10 divided by 2 is what? -5. So you should have a value of -5. However, when you put it into the calculator or a computer, you will do -7, you have that, plus -3, right? Or you say divided by 2. What do you think the computer will do or a calculator will do? They will follow the order of operation because that's how we program them. If you write it this way, what do you think a computer will do? You have division, you have plus, right? They will do the division first. -3 divided by 2 is -1.5, then plus -7, that would be what? -8.5. It's different from the value we expected, right? However, if you do this way, if you put a parenthesis around it, divided by 2, so you are telling the calculator you will do the group first. They will follow the order of operations. Okay, so -7 plus 3, -3 is what? -10. Then we'll divide by 2. You will get a -5. So that's correct. Okay, so for this problem, we don't do this way. When you enter to the computer or calculator, you do it this way, right? So let's go back to the facts about the parentheses. Let's read through, okay, because it's important. So for the hidden parentheses, you may think that since you always have a calculator or computer at hand, that you don't need to worry about order of operations. Unfortunately, the way that expressions are written is not the same as the way that they are entered into a computer or calculator. In particular, exponents need to be treated with care as do fraction bars. That's what happened to our fraction bars. Then for the exponents, remember we have something like last time 4.12 plus 4, situation like this. Then because you have to do exponents then first, so you have to enter the calculator by the head symbol, right? We call it head symbol. Then plus 4, because you have to perform the exponents first. If you enter 4.1 head 2 plus 4, by order of operations, you will do the exponents first before you add 4. Then you get a different result. So we don't do that, right? So you do need to follow the order of operations to express the idea into the calculator before you can do it right. Also, it says there are many formulas that are encountered in a statistic class, and the value of each variable will be given. It will be your task to carefully evaluate the expression after plugging in each of the given values into the formula. In order to be successful, you should not rush through the process, and you need to be aware of the order of operations and use parentheses, right, when necessary. So it's important you do that. We couldn't emphasize, enough to remind you. So you need to be careful. So stats, it has many words. Then we have to map the words to the math expressions or math statements, we call them. Okay? So let's look at the next question to figure out what do we need to do mathematically according to what they say. Okay? So let's read through the problem first, then we explain. Suppose that equation of the regression line for the number of days a week, x, a person exercise, and the number of days, y hat, a year a person is sick, is y hat equals 12.5 minus 1.6x, right? We use y hat instead of y, since this is a prediction instead of actual data values y coordinates. Use this regression line to predict the number of times a person who exercises 4 days a week will be sick this year. So when you look at the problem, first time you may get dizzy. Okay, you say, what do they want us to do? So you have to figure out what do you need to do. So let's read through question first. Suppose that equation, something called equation of a regression line. So when you read this problem, first, you don't understand what a regression line is. Okay? For the number of days a week, x, at least you see, is what? The number of days a week per week, okay? A person exercise. So x means what? You use the symbol x to represent the idea number of days per week you exercise. If you exercise 2 days a week, x would be 2. If you exercise 3 days a week, that would be 3, right? Then a person is sick is, so you have y hat, okay? You use this symbol, stats use that a lot. Is 12.5 minus 1.6x. You have no idea what it is, right? But you know y hat is a year a person is sick. So this is the sick days of the person, right? Per year. How many days the person will be sick, right? Now you start to kind of understand what is X, what is Y hat represent at this moment. X is what? The number of days the person you do exercise. Then it will cost how many sick days per year. Okay? Then we follow through. Then see what happened. We use Y hat. All right? Not Y at this moment. When we do the prediction, it may or may not happen, right? It's just estimate. So hat means estimate, okay? So a prediction instead of actual data value is y coordinate. You don't know what a y coordinate yet, all right? So just instead of y, use this regression line to predict the number of times a person who exercises 4 days a week, how many days he will be sick, right? So you don't understand regression line, then you know it's a line. Regression line is, you might predict. That's what we are talking about. This is a line, but you don't know yet, right? Line is supposed to be line, but you haven't learned how to graph yet, so you don't understand what it is. But for the moment, okay, let's look at the question. Then we are going to, all those are express an idea with the variable, okay? So let's do some analysis. So, okay, so what does this one really mean? But X is number of days per week that the person exercise. So what do you think? The person can exercise 0 day, right, per week. X can be 1, X can be 2, X can be 3, 4. How many days per week? 7, right? That's your possible X values. Then Y hat means what? It's a Y value. Y value is according to your according to your X. Then X can be this value, so you plug in and see what happens. If you do 12.5 minus 1.6 times 0, right? That means two symbols together, one number, one variable. It means multiplication, right? Then this one would be what? Y hat is 12.5 minus what? That's what it's saying, right? Then this one would be Y hat equals 12.5 minus, I just spelled it out for you. So you can see what does that Y hat mean, okay, intended to be. So you do that. Y hat 1.5 minus 1.6 times 5, right? X is 6, then you will do what? Right? Then if Y 1 week is 7 days, maximum will be 7 days. So you will plug in your X is 7. That's how you find a value, okay? Then you plug in the number, X equals how many days per week you exercise. Then you calculate this value, so that would be 12.5. Let me just write down the number for you. Then we see what do we try to set, right? So what does Y hat stand for? How many sick days of the person will have per year? So if this person exercises 0 day a week, he will be sick 12 days per year. All right, not necessary to be true, but we are talking about what? Y hat prediction. Okay, so stats is all about a bunch of data and you do some prediction, right? So prediction may not always be true, but sometimes it does, right? So if X is 1, it means what? If this person exercise 1 day per week, his sick day per year will be 10, 11 days. 2 days per week, he will be sick. 9 days, 3 days a week with 6, 7 days. 4 days a week would be 6 days per year. 5 days, according to the prediction formula given to you, right? So if you exercise 7 days a week, you might be sick, all right, 1 day per year. See, if you exercise more days, that means you drop your sick days. That means the more exercise you have, the less sick you will be, in general speaking, right? So that's what it means. That's what a bunch of words is saying. Then you have to answer the question. What was the question? Look at the last one, last sentence on your question. It says, use this regression line, okay, to predict the number of times a person who exercises 4 days a week will be sick this year. How many times he will be sick? Okay, so the question is, if you exercise 4 days a week, how many times you will be sick? 6.1, right? So what kind of conclusion you can make? Try to make a conclusion with a full sentence, okay? So you would say, how would you say it? Okay, let's write it out for the conclusion. Okay, so we are talking about, from the question, we need to find out for a person, you know, X is 4, right? Means what? Who exercised 4 days per week, right? Is that the person, he or she, will be sick, right? 6 times this year. According to the prediction formula given to you, the conclusion you can make is, for a person who exercises 4 days per week, is that the person will be sick 6 times this year. That was the question. You get used to all the words with a little equation, then you draw a conclusion. Okay, so since we are predicting the number of days a year being sick, it is good idea to round the nearest whole number. It was 6.1, right? Then we just say, you know, the 6 rounded to the whole number. We get that the best prediction for the number of sick days for a person who exercises 4 days per week, okay, is that there would be 6 days this year. Got idea? Okay, so we are learning what? For this, we call it equation, right? Then this is a math language. then you translate bunch English into the math language and use this to draw a conclusion. Okay, that's what we need to do in this class. Let's look at the next one, page 16, problem 3. Okay, let's read through first, then figure out what we need to do. It says, the z-score is defined by such way. Okay, find the z-score rounded to 1 decimal place if x is 2.323, mu is 1.297, sigma is 0.241. Okay, that was the question. So it says z-score. This formula is called z-score. You are going to learn this in your stats class, why it's this way. But for the moment, we are learning the terminologies, names, vocabularies, right? And some symbols. So that's the purpose of this class, to get you ready for the stats class. So it says, okay, my formula z is this. We call this z, call z-score. Some score, just like your grade, your score is such way for a purpose to determine something, right? At this moment, x is given this number, mu is this number, sigma is this number. It says what? Find the z-score. That means what? Find the z value. What do you think you need to do? Plug in, right? So, what do? So your z is what? X minus mu. So you plug in. X is 2.323 minus mu is 1.297, right? Over sigma, 0.241. Then you put it into the calculator to do it. Then we say when you put it into the calculator, you need to pay attention with your parentheses, right? Follow the order of operations. So this is a group symbol. The top is group. So you need to put into the calculator this way. You have to do this group first, then divide by this value. Okay? Then you will have 4.25726, some number. Then it says rounded to 1 decimal place. So that's 1 decimal place is here. You don't want the remaining decimals, right? Then this one you have to round up. So your answer would be what? 4.3. Plug in and practice the numbers. That's the idea, right, for this class. That means we are going to evaluate the result. Okay? Doing that is not too bad. But understand what you need to do on the question, right? It's what you need to learn. Okay. Next one, number 4. For a yes or no question, a sample size is considered large enough to use a normal distribution. Okay, so it's talking about sample size. You haven't seen it before. And something called normal distribution. You have no idea what it is. Okay. Under this condition, it says NP greater than 5, NQ greater than 5. If. Okay? So, it says for a yes or no question, a sample size a sample size is considered big enough to use normal distribution if condition is this. So you don't know what n is, you have no idea what n is talking about, p is talking about, q is talking about. But at least you know np multiplying together, right? Let's continue read through. It says where n is the sample size. N is what? The sample size. P is the portion. Yes, answer. P is the portion of yes, answer. Q is the portion of what? No, answer. Portion means what? Part of a whole, less than, or equal to 1, up to 1, the whole. Or it will not happen. If it will not happen, that would be 0, right? So it explained it to you when we use the thing NPQ. What do they mean? Okay? Let's read the question again. For a yes/no question, a sample size is considered large enough. You have no idea what do we want something for, we call it large enough. Okay. So for yes/no question, a sample size is considered large enough to use normal distribution if this condition happen, right? Then NPQ are those things. Then a survey was given to what? It says 59 person say they will feel insecure today. Okay, survey is saying you have 59 person for the survey, right? Okay, let me see. Then they ask them if they will feel secure today. Then it says 6.8% of them say they'll feel insecure. Was the sample size enough to use the normal distribution? So you look at the question, you don't even know what they are asking. So let's repeat. It says, was the sample size large enough to use the normal distribution? We are talking about whether or not the sample size is large enough to use this formula, something called normal distribution. Okay, only under certain condition you can use normal distribution if the condition is met. Okay, so that means n has to be big enough. N is your sample size. So the question is whether or not was the sample size large enough to use the normal distribution. What's your sample size? It says sample size is the size of the survey. That's your n. Okay, so you have to match the number with the symbol, which symbol is using for what. Okay, so it means you have 59 people surveyed. That means your sample size, right? Then it says 6.8% say data is insecure. So we have to find it out. So that's your n. So what's your p? What is your q? P is portion of yes. Okay, say, we are survey for what? If they are full, insecure. We are talking about insecurity, insecure. How many say yes on insecure? What do you think? Yes, insecure. On insecurity, right? How many say yes? That's that number, 6.8, right? Then how many say no? What do you think? Okay, so when yes is 6.8%, so you change to decimals, so 0.68, right? Then whole population, we call it 1. So portion is say 0.068 is say yes, the remaining we say no, right? So you do 1 minus 0.068, that would be what? 0.9. So 93.2% people, we say no. So you will identify all the things we needed with numbers. That's what it's saying. Okay? Then how can we decide the sample size? The question was the sample size N is big enough to use the normal, something called normal distribution. Okay, you don't know what's that yet, but you will learn that in stats class. Something called normal distribution we need to use. It's just, something. Under certain condition like this, if this condition is met. So how can you decide? Then you check the condition, whether or not the condition is met. Then you decide whether or not you can use the normal distribution, right? So we need to check NP. What is NP? N times P. N times P. Right? Then you get what? Let me see what kind of number we get. 4.012. Then if you do NQ, you do 59 times point here, 932 is what? 54,988. How do we make a decision? It says if both are bigger than 5. So we look at this. This one is less than 5. This one is bigger than 5. So do you have both bigger than 5? No. So can you use the normal distribution concept? Okay. So practice, write the conclusion. Okay. So it's saying what? The sample size 59, right? Was big enough because it's less than 5. It doesn't satisfy the condition, right? Was no, so you cannot. Was not large enough to use the things we say call normal distribution. Okay, so what we try to do, what we want you to learn is get familiar with the terms. Then something called normal distribution, something called sample size. Okay, then some formulas we use to make a decision. At the same time, answer the question. Okay, was this sample size big enough? Sample size 59 to take a survey. So what can you do? If you increase the survey size to 70, 7 maybe big enough. That means you need to do more surveys to make it something called normal distribution. Okay? But doing that, you need to do the math part. But first, you have to, to connect your English, your words, the meaning of words to the things we try to pursue. Got it? Okay. Let's look at the next one. Number 5. Okay. Here says, based on the central limit theorem, the standard deviation of the sample distribution when samples of size n are taken from a population with standard deviation sigma is given by something, right? If the population standard deviation for the number of customers who walk into a fast food restaurant is 12, what is the standard deviation of the sample distribution for samples of size 35? Round your answer to 2 decimal places. Let's read it many times, okay? Until you get familiar with the names, terminologies, and a little bit familiar with the formula. Then we go from there. So let's do it again. Based on the central limit theorem. So they talk about something called this one. You have no idea, right? You will learn this later. But you know some names called central limit theorem. And it says the standard deviation. So you have something called standard deviation. That's new to you, right? Of the sampling distribution. You don't know what that is, right? Then you also say sample size. Sample size is n. At least you know the symbol n means sample size. Okay? Then another one is saying from a population with the standard deviation is sigma. Okay? So let's see. It's given by something like this. Bar equals sigma over n, right? So when you see a formula given to you, you need to understand each symbol, what do they stand for. Okay? It says if the population standard deviation, so I have a population standard deviation for the number of customers who walk into a fast food restaurant is 12. So it says something is 12. 12 is which one? It's n or your sigma x bar, right? We need to connect that. Then what is standard deviation of sampling distribution for sample of size 35? Round your answer to 2 decimal places. Okay, let's do it again. We have no idea what is central limit theory. But in the question, we are not using that, right? But it says the standard deviation of sample distribution when sample size n are taken from a population with standard deviation sigma. So it says sigma is what? So for these things we want to find, first we have to identify what is sigma, right? What is n? Then we can find sigma, whatever that is, right? Then you have to identify with all the words we say here, with this formula, with the numbers, right? But if you look at the, say, for sampling distribution, for sample of size 35, so sample size is n, right? So it says sample size is what? 35. So you know your n is the sample size, which is 35. It's given, right, in the question. But we need to find the sigma. What is sigma? On your second line of the question, it says they are taken from a population with standard deviation sigma. Okay, so standard deviation is your sigma. Okay, so it's a population. Now you still have problem what is called sample, what is population. We will go into the detail in stats class to identify what is population, what is sample in general. But for the moment, it's very confusing for you. Okay, so, but you say population with standard, on your second line, population with standard deviation sigma. So sigma means what? Population with standard deviation. It's what? Population with standard deviation is what? It's given, right? For this one. So take a look. On the, after the formula on your paper, it says if the population standard deviation for the number of customers who walk into a fast food restaurant is 12. Okay, so we are talking about the standard deviation for the population is 12. Which 12 is for what? The customers who walk into a fast food restaurant. And what do we need to find? Round your answer to the 2 decimal places. What is the standard deviation of the sample distribution? Okay, so we want to find the standard deviation for the distribution. That means what? This guy. This is this. So we use this symbol for the standard deviation. All right, sigma x bar. Then we use the sigma is for something called population. Confusing enough? Okay, so bunch of words, you have different symbols. One is n, one is a sigma, one is a sigma x bar. Okay, so we want you to find the sigma x bar. First, you ask you, okay, what is standard deviation of sampling distribution? So this one, standard deviation for sampling, the data you are using, sampling data, right? Sampling data. Confusing enough. So you need to identify, you have 3 symbols here. You need to identify which symbol we want you to find. Which symbol is given. So this question, we say, okay, if I give you this formula, then we want you to find the sigma x bar with given sigma and n. Of course you can find it. Because sigma is 12, n is 35. You just plug in, you can find it, right? But among all those words, it says, what is standard deviation of sampling distribution? What's the standard deviation, sigma, for the sampling distribution? That's this guy. We want you to find this, but according to the words, okay, on the top, it says, second line, population with standard deviation, right? Population with standard deviation sigma. So it tells you sigma is what? Population with standard deviation, right? Then n is the sample size. It says sample size 35. So n is sample size 35. Then we want to find the standard deviation of the sample distribution. That's that guy. Still confusing enough for you for the moment. Okay? So we practice that. So we want to, doing that is not bad. So sigma is 12, n is what? 35. According to this formula, you should do that. Right? Then we put into the calculator. Remember, this line is what? A group symbol. So we need to do what? 12 divided by this group, right? Because you are 35, square root of 35 is what? We put the 0.5 as power, right? This one half is the power, so you use the, we say square root, you use half power. On your chapter 1, we practice that. Then you need to do that. Okay? So when you put into the calculator, you do divide, but remember, you need to have parentheses. Then you get this number, 2.02837, da, da, da. Okay, how many decimals do we need? 2. So we don't want this, we round up. So the answer is 2.3. So, right? What does that mean? It means, okay, what kind of answer is that? So you do conclusion, practice that. You need this for your stats class. So we are talking about this guy, sigma x bar, right? Is this standard deviation of sample distribution, right? So you will say the standard deviation of the sample distribution, right? Is 2.03. Okay, you still don't understand what the standard deviation, standard speaking, deviate from something of the sample distribution is 2.03. Okay, so we are practicing mainly is how to plug in, but which number to plug into where, that's what you try to connect for this section, right? Confusing enough? That's what it is, right? That's what we are here to get familiar with all the names. Doing math, I think you can do it. Then now the difficulty is all those terminologies, you don't really know the meaning in depth yet, okay, until you take a stats class. But we need this foundation, how to calculate things first. Okay? Are we okay? Probably not, but you get over it. Okay, so this will cover our section 2.2.